LLM agents for automated web vulnerability reproduction. Are we there yet?
The paper's abstract states that agents consistently fail on complex, service-based vulnerabilities that require multi-component environments. This paper investigates the gap between the claimed potential and demonstrated capability of LLM agents for vulnerability reproduction. According to the paper, manual vulnerability reproduction is a bottleneck. The process is slow and resource-intensive, creating a validation gap in security operations. LLM agents are proposed to address this, but the paper notes their practical effectiveness for this task lacks empirical validation.
What was the methodology used to construct a test for these agent capabilities?
The study used a four-step workflow: data preparation, agent selection, task specification, and evaluation.
The paper constructed a benchmark dataset using 80 real-world CVEs.
The dataset covers 7 types of vulnerabilities, such as CSRF and RCE, and 6 web technologies, including PHP and JavaScript.
How were the specific agents for the in-depth analysis selected?
The paper first assessed 20 agents, then selected the top 3 for detailed analysis: OpenHands, SWE-agent, and CAI.
4 evaluation tasks were designed to measure agent performance: environment setup, vulnerability localization, POC generation, and end-to-end reproduction.
What were the primary quantitative findings from the evaluation?
According to LLM agents for automated web vulnerability reproduction, are we there yet? Overall end-to-end success rates are low. The best-performing agent, OpenHands with Claude 4, had a success at 3 rate of 22.5%.
And this performance varied by vulnerability type.
The paper reports higher success with library-based vulnerabilities. Agents consistently failed on service-based vulnerabilities due to the complexity of the environments.
The data also shows performance varied by web technology, with PHP at 38.9% success.
What does the paper identify as the primary reason for these low success rates?
The paper reports a critical gap between POC execution and vulnerability triggering. According to the paper, agents achieved POC execution success rates from 25% to 70%, but vulnerability trigger rates were only 8.8% to 21.3%.
What causes this execution to trigger gap?
The paper identifies 2 main failure points. First, environment complexity. Agents struggle with database setup and deployment. Second, authentication. Agents are unable to perform automated logins required to trigger vulnerabilities.
How does the authentication requirement impact agent performance?
According to the paper, performance degrades by an average of 33.3% when agents must handle login autonomously. The conclusion is that a gap exists between current agent capabilities and the demands of reliable automation.
What are the actionable takeaways from this analysis? Improve environmental adaptation for complex services, according to LLM agents for automated web vulnerability reproduction. Are we there yet? Enhance autonomous problem-solving capabilities, according to LLM agents for automated web vulnerability reproduction. Are we here yet? Bridge the gap between exploit execution and vulnerability triggering, according to LLM agents for automated web vulnerability reproduction. Are we there yet? Develop robust methods for handling authentication, according to LLM agents for automated web vulnerability reproduction. Are we there yet? And focus research on systems-level understanding, not just code analysis, according to LLM agents for automated web vulnerability reproduction. Are we there yet?
This raises a final question. What fundamental capability must agents develop to be trusted with this task? The paper indicates a systems-level understanding of applications is required.